So today we are going to be graphing exponential functions. And if you remember, the parent function for all types of exponentials look like that. And your asymptote is right here at y equals 0. It will never touch that red line, but it will get very close, okay? So let's go ahead and graph these. The first one we're going to graph is f of x 2 to the power of x. That's our first function that we're going to graph. What's my base here? 2. So everyone put the base. And guys, I just graphed it for you right here. What's my domain? Yep, it'll go forever left, forever right. It will always be all real numbers. You can also write it like this, negative infinity to infinity, or you can write it like this, negative infinity to positive infinity. Those are the 3 different ways you'll see it written. The range, looking at the graph that I just drew, where's the very bottom? 0. It does not go past this line. So the bottom is at 0, and then it goes up from there. So the range is 0 to infinity. You can also write y is bigger than 0. The graph is above 0, greater than 0. And where does my asymptote cross the y-axis? At 0. So your asymptote is 0. So guys, this part is all review. We did these the last few days. Let me show you the part that is new. So let's fill out a table. My base is always 2. So my base is 2 for all of these. What I am substituting is this x. Okay, so we are going to plug in negative 2 for x, then negative 1 for the x, then a 0, a 1, and then a 2. We're plugging in those x values. Okay, so I'm going to start in the middle of the graph. 2 raised to the power of 0 is always 1. Anything with a 0 power is 1. If I have 25 raised to the 0, it's 1. 50 raised to the 0 is 1. Anything with the power 0 is 1, okay? Anything to the power of 1 is just itself. Okay, and then guys, what is 2 to the power of 2? 4. 2 squared is 4. Okay, now let's figure out these negative exponents. Let me remind you guys, if I have a number raised to a negative exponent, do you guys remember how we write this? Yes, exactly. I'm going to put a 1 in the numerator, and I'm going to put this x to the a in the denominator, and it becomes positive. So to make a negative exponent positive, you put it in the denominator. Okay, so for example, if I had 9 to the negative 4, I would write this as 9 to the 4th power, put it in the denominator to make it positive, and just put 1 in the numerator. Okay, that's the rule. Okay, so over here, for my table, to make this a positive exponent, we'll put it in the denominator. So what will my answer be? 1 over 4. It's basically this one flipped. Okay, let's do the second one. This will be 1 over 2 to the power of 1. What will this become? 1/2. It's just this one flipped. Okay, so now that I have my points, let me highlight what I have. When x is negative 2, the y value is 1/4. When x is negative 1, the y value is 1/2. When x is 0, the y value is 1, 1, 2, 2, 4. These are my points that I'm going to put into the table. So guys, let's go ahead and graph these. Okay, So -2 1/4, this is the x-axis down here. This is the y-axis, just so you can tell. Okay, so -2 1/4 is really close to the x-axis. It's really small. It's down here somewhere. -1.5, that's about right there. Okay, 0, 1 is right here. 1, 2 is there. 2, 4 is here. And if I wanted to add another point in my table, if I plug in a 3, what is 2 times 2 times a third 2? 8. 2 times 2 is 4, times another 2 is 8. So if I want to graph that, 3 to the 8 is right there. Okay, so notice, and guys, if I put in a -3 here, what do you think the y value will be? 1/8. It just flips. So it would be really small, but notice it's never 0. It just gets really close. So guys, go ahead and connect your points. That's your graph. And that is your parent function. All right, let's go ahead and do the next parent function. We're going to do base 10 this time. So this time we're going to do f of x equals 10 to the power of x. The base is 10 this time. So we just did base 2. Now we're going to do base 10. In your domain, it stays the same. All of these will be the same. Okay. So we're going to be doing base 10 this time. I have 10 to the -2 power. How do I rewrite this? Yep. So you just put the exponent in the denominator and make it positive. So guys, 1 over, what is 10 squared? 100. That's a really small number. Very close to 0, but we're never going to equal 0 because there's an asymptote there. Next one, 10 to the -1 power. How do we rewrite this? 1 over 10 to the first power, perfect. And what will the answer be? 1 over 10. Next, 10 to the 0 is what? Yes, anything to the power of 0 is 1. 10 to the power of 1 is 10. Anything to the power of 1 is itself. And then what is 10 squared? 100. 10 times 10 is 100. Okay, so let's graph it. -2 1/10, that's really close to 0. I'll put the dot right there. -1 1/10, that's also very close to 0. 0 1 is right there. 110 is way up here. And 210 is off the graph, so it's growing very fast. All right, so this is my graph. And remember, your asymptote is right here. It will not touch that line. Okay, last one. We're going to now do base E. Let's do base E. Okay, so now we're going to do e to the power of x. All of this will stay the same. Your domain is the same, your range is the same, your asymptote is the same. All the parent functions have the same attributes. Okay, what you need to know is that E is approximately 2.718. E is approximately 2.718. So we're going to always do base E, and we're plugging in a -2. How do I rewrite this? 1 over, yep, e to the second power. It just becomes positive when you put it in the denominator. Okay, guys, go ahead and grab your calculators. I need to know what 2.718 times 2.718 is. 7.387, perfect, thank you. So that's just a number very close to 0. Let's do the next one. E to the -1 power, or negative first power. Put it as 1 over e to the first power. Guys, what is anything to the first power? Itself. Okay, and we said e was 2.718. So that is that one. E is just 2.718. Whenever you see E, it's about 2.7, okay? All right, now we're gonna do E to the 0. What is anything to the 0 power? 1. What is E to the first power? Itself, right? So 2.718. And then we're gonna do E squared. And we said 2.718 times 2.718 is 7.387. All right, so let's graph that. -2 and 1 over e squared, it's a very small number. It's very close to 0. So just draw a point close to 0. Next one at -1, that's also close to 0. E to the 0, we got 0, 1, 1, and then 2.7, that's between 2 and 3. So I'm going to go about right here. And 7.3, that's about right here, between 6 and 7. I'm sorry, between 7 and 8. All right, and then connect your points. That's your graph. They all have the asymptote at y equals 0. Okay, is everyone okay with how we graph these? You just plug in numbers, find the numbers, and plot the points. Now we're going to do transformations. Okay, so guys, the parent function is already graphed. We just graphed it. It's right here in purple. The transformation that they gave us, what happened to this equation here? Yes, it went to the right 3. Everyone write that down. It went to the right 3 spaces. So guys, let's just plot some points here. If this graph moved over 3 spaces, it's now here. Move this over 3 spaces, it's now here. Move this over 3 spaces, it's right here. Move this 3 spaces, it's right here. So this is your new graph. Make sense? It moved to the right 3, so just move it over 3. And then you just answered this question. It looks like your domain didn't change at all. Your range didn't change at all. And your asymptote didn't change. It's because your range and asymptote only change when you go up or down, or if it's reflected. All right, let's try another one real quick. How did this one transform? Yep, reflect over the x-axis. And it went up 4. So because there is a negative in the front, it's going to reflect across the x-axis. So guys, what will happen is this graph will now be facing down, like that. Okay, don't draw this yet because we're not done. That's only one transformation. The other one is that it went up 4. Okay, so guys, let's look at this asymptote. Here is the asymptote. We're going to move this asymptote up 4 spaces. Okay, so 1, 2, 3, 4. Your asymptote is right here. So this is your new graph. Okay, so that is our graph. Now our asymptote is now at 4. So guys, this part stays the same. The parent function here is f of x. 10 to the x, right? Our base is 10. So that's the parent function. This remains the same. Okay, however, what is new? The domain did not change. For exponentials, it is always all real numbers, no matter if it was reflected, shifted, left, right, up, down, the domain stays the same. Now, guys, what is my new range? Y is less than 4. Perfect. The asymptote is at 4, which makes sense because look, I have a +4 right here. That should always match. So your asymptote is also 4. Now the range, you can also write it as -infinity to 4. Can you please write it both ways so that we get familiar with this? This version of the range is this is interval form, and this is inequality form. Make sure you're familiar with the different ways to write the range. Also, if you wrote it in set notation, I'll just write it down here as a note. You don't have to write this, just reviewing. Set notation, you'll just have the curly bracket, and then you'll write y less than 4. That's how you write it in set notation. Okay, next example. Okay, so guys, this was reflected across not the x-axis, it's on the inside. So this is reflect across the y-axis. So guys, instead of going like this, if it was reflected across the x-axis, it is now going to look like this. That is what it's going to look like. Don't draw it yet because we're not done with our transformations. So it reflected across the y-axis. And let me make sure this makes sense to you. You see how this point matches that one? Think of the y-axis as the mirror. You see how this point mirrors this point mirrors that point, this point over here mirrors this point over here. It reflected across the y-axis, okay? So that's what it will look like. The y-axis is the mirror, and it just flipped across. Okay, so that is our new graph. However, let's add some more things to it. What else happened in our transformation? Down 2. So guys, take your asymptote. Here's your asymptote right here. Move it down 2 spaces. So you should be down here now. Everyone draw that asymptote. We're going to scoot our graph down to our asymptote. So now we reflected across the y-axis and we moved it down 2. So it looks like this. Okay, so that's our final graph. Always graph your reflection first. Reflect it and then move it, however many it says. Okay, so first we reflected across the y-axis and then we moved it down 2 spaces. Okay, so let's talk about our transformations. First, let me just fill this part out again. The parent function, what was my base for this one? E, the base was E. So the parent function is e to the x. This information remains the same. It'll be the same for every parent function here. Okay, domain will always be the same. What changed is the range. Can you guys tell me what the range is? Yes, y is greater than -2. So this is inequality form. Let's also do interval form. Perfect, thank you. -2 to infinity. The very bottom is at -2 and it's above that. So it goes off to infinity. And what's my asymptote? -2. So guys, you really don't even have to look at the graph. They gave you the equation. Okay. Only if there is a negative in the very front. So guys, look at my pen. I'm going to draw it in purple. No, I'll do it in green. Only if there's a negative in front will your range change? Okay? There's not a negative in the front. So what I mean by change is, you see the symbol here? The symbols are the same. You have a greater than symbol and you have a greater than symbol. Infinity came second. Only if there's a negative in the very front will your symbols change. And negative infinity will be in the front. Okay? All right. Let's do the last example. Here we go, last example. Okay, so let's talk about the transformations here. We're given this function. What were the transformations here? Right 1 and up 2. All right, guys, so I'm just going to talk about this real quick. It went right 1, up 2. So this is a point, right 1, up 2. And it says the new function was translated 3 units to the left and 1 unit down. So let's do that. 3 units to the left. Okay, so from this point, it went 3 units to the left. That's 1, 2, 3, right here. Is that okay? Yes. Yeah, okay. And then down 1. So I'm going to go down 1 space. So this is where my new point is. I started right 1, up 2. I'm starting at the origin, by the way. I go right 1, up 2. That's from what they gave me. And they changed it 3 left, down 1. So this is my new point right here. So guys, what is the location of that new point? This new point here, what's the location, the coordinate? Thank you, -2, 1. So let's go ahead and write my equation. Y equals, the base was 2, so I'm gonna put a 2 there. Okay, so guys, what am I gonna put in the place of C? Just a 2? So I'm gonna put in this right here, this -2, and it becomes a +2, which makes sense because it's on the left side. And then what do I put for the letter D? Just the 1. Because if you talk about this from the origin, this is now left 2, up 1. Left 2, up 1. So this is your equation. All right, guys, that is the end of our notes. You guys are doing the next page, page 11 and 12. Page 11 and 12. What you don't finish in class is homework.